A flash of an instant against a 14-billion-year-old cosmos. Maybe extraterrestrial technology bears no resemblance to ours, and we are hunting for the incorrect variety of transmission entirely, anticipating radio waves from a society that discarded radio the way we discarded smoke signals. Some venture even further, proposing advanced societies already recognize we exist and are intentionally remaining silent, observing from afar the way a wildlife researcher studies a creature without interrupting its environment, a version of events occasionally labeled the zoo hypothesis. It is a gratifying narrative because it converts quiet into a decision rather than an absence, and a decision feels less alarming than a void. Each of these explanations is sensible on its own. Distance is genuine. Duration is genuine. Our detection methods are constrained for decades. This is where most interpretations of the Fermi Paradox have paused. Not because the riddle is cracked, but because these responses are soothing enough to close the discussion. They let you trust the cosmos is still populated. Just hush for practical reasons. Reasons that will ultimately sort themselves out as our instruments advance. Consider how limited our hunt has truly been. The modern Breakthrough Listen initiative, the most extensive search of its type, has surveyed only a fraction of the electromagnetic range, directed at a minor portion of nearby stars, for a cumulative listening duration that amounts to less than a rounding error against the lifespan of the galaxy. Astronomer Jill Tarter likened it to scooping a cup into the ocean and deciding there are no fish because the cup surfaced empty. By that measure, quiet is not proof of absence. It is proof that we have scarcely begun searching. If these figures are already making your mind reel, you are precisely where you ought to be. Hit like now, because it only grows more bewildering from here. But here's where the reassuring explanations begin to crumble, including the neat notion that someone out there is observing and purposely remaining quiet. That narrative demands every single society across every culture, every value system, every degree of curiosity to independently settle on the identical policy of restraint without exception forever. Even one inquisitive outlier, one probe, one transmission, one error would shatter the quiet entirely. Run the figures on colonization velocity, not transmission velocity. A society does not require faster than light travel to populate a galaxy. It just requires duration, persistence, and self-copying machines. Physicist Frank Tipler and mathematician John von Neumann both calculated the mechanics, a probe that can move at even 1% of the speed of light, and assemble 2 replicas of itself at each new star system it occupies, could settle every star in the Milky Way in approximately 10 million years. Physicist Freeman Dyson extended the concept further, envisioning societies that would not merely visit stars, but disassemble them, constructing enormous shells of solar collectors to capture their complete energy output. That sounds immense until you recall the galaxy is over 10 billion years old. 10 million years is a rounding error, less than 0.1% of the galaxy's lifespan, which means any society that achieves spacefaring capability, even once at any moment across 10 billion years of galactic history, should have had more than adequate duration to physically inhabit every star system in the galaxy, including this one. The notion that we simply have not been tuned in long enough quietly presumes the extraterrestrials are also newcomers to space travel operating on our schedule. Observation says. Otherwise, given the age of the galaxy, quiet is not what you would anticipate from a society that has not arrived here yet. It is what you would anticipate from a galaxy where a spacefaring society has truly never existed or never endures long enough to become one. Picture this. You plant one tree. That tree scatters seeds, and 2 years later there are 2 trees. Those 2 trees each scatter seeds of their own. And in 2 more years there are 4. If nothing intervenes, the count of trees doubles every generation, and forests reshape entire land masses in a geological flash. Now substitute the trees with self-copying spacecraft, and substitute the forest with a galaxy of 400 billion stars. Each vessel arrives at a new star system, extracts local materials, constructs 2 additional vessels, and continues onward. The exponential arithmetic is a part your instinct resists. It does not seem like 10 million years should suffice to span 400 billion stars, because your brain is not designed to envision doubling, but doubling is misleadingly rapid. Begin with 1 vessel and double it 40 times, and you already possess over a trillion. You would exhaust stars to occupy long before you exhausted doublings. So, if the physics of self-replication truly allows this, And if even one society anywhere across 10 billion years of galactic history possessed a resolve to attempt it, this solar system should already display traces of an ancient probe, a remnant, of framework harvesting. Starlight, something. Astronomer Nikolai Kardashev proposed a classification for precisely this type of society. A Type 2 society potent enough to harness the complete energy output of its home star would leave a measurable signature, a star emitting warmth in infrared rather than visible light enveloped in the waste heat of a framework, constructed to capture its energy. Surveys of millions of stars have hunted for precisely that signature. They have discovered nothing, no dim stars. Glowing suspiciously in infrared, no megastructures, no remnants, not even the debris of a society that attempted this and crumbled partway through. Observation does not demand an extraterrestrial standing in your driveway. It only demands the figures to succeed once, and they have not materialized. So if the arithmetic functions and the duration is available and nothing here reveals any trace of it ever occurring, what does physics declare is actually preventing it? Physics presents three explanations for quiet layered on top of one another, each one tightening the odds further. The first is what is termed rare Earth. Complex life does not merely require a planet in the habitable zone, the region where liquid water can persist. It requires a star that burns consistently for billions of years without flaring intensely enough to sterilize its planets, which eliminates most of the stars in the galaxy, since the majority are unstable red dwarfs. It requires a planet with plate, tectonics recycling carbon and moderating temperature across geological duration. It requires a large moon steadying axial tilt, so the climate does not veer erratically. It likely requires a gas giant in the outer solar system, clearing comets and asteroids before they become extinction catastrophes. It requires a molten core producing a magnetic field robust enough to repel solar wind, shielding an atmosphere that would otherwise be stripped away across millions of years. The way Mars rendered most of its own, Earth satisfies every one of these criteria. Statistically, that is not the anticipated result. It is an improbability piled on an improbability. Piled on an improbability. Multiply enough low-likelihood prerequisites together, and the count of genuinely Earth-like worlds contracts from billions down to a handful, perhaps even one. The second explanation is grimmer. It is termed the Great Filter, a phrase introduced by economist Robin Hanson. The concept is straightforward and disquieting, somewhere between the initial spark of chemistry and a society equipped to colonize other star systems. There is a stage so improbable or so perilous that virtually nothing passes through it. A range of major transitions life on Earth actually had to endure, from self-replicating molecules to simple cells to complex cells to multicellular organisms to tool-wielding intelligence to technology capable of reaching other stars. And at least one of those transitions must be improbable enough to account for why the galaxy is not already occupied. Examine Earth's own chronology and the candidates emerge immediately. Life materialized almost as soon as the planet cooled sufficiently to permit it, which implies abiogenesis might genuinely be straightforward, but then nothing occurred for 2 billion years. Single cells remained single cells generation after generation with no intricacy, no specialization, nothing approximating the subsequent stage. For a stretch of duration longer than complex life has existed since, or maybe the filter is not behind us at all. Maybe it lies ahead of us, a phase every sufficiently developed society reaches and fails to survive, nuclear arsenals, engineered diseases, uncontrolled artificial intelligence, ecological devastation from its own industrial triumph. If the filter is ahead, then the quiet is not comforting. It is a caution. The cosmos may be filled with societies that advance exactly as far as we have and no further. The third explanation is the most frigid one because it does not require any society to collapse at all. It only requires the geometry of space-time to work against them. No transmission, no vessel, no information of any variety can travel faster than light. That is not a technological barrier awaiting an engineering workaround. It is a structural characteristic of the cosmos itself encoded in the mathematics of relativity, which means for two societies ever establish contact, they do not merely need to exist at the same moment. They need to exist within light travel range of each other during the slim window when both happen to be transmitting or receiving at the same instant in a 14 billion year chronology. Societies may not persist very long relative to that chronology. Radio capability on Earth is barely 100 years old. If most technological societies burn intensely and fade out within a few thousand years through disintegration, annihilation, or simply transcending radio the way we're already beginning to, the probability of two such brief flashes coinciding across a galaxy 100,000 light-years wide becomes infinitesimally small. Two societies that both exist, both could be perceptive, inquisitive, and actively searching, and they could still bypass each other entirely, divided not by reluctance, but by the merciless arithmetic of light speed and duration. Which of those three explanations strikes you as most probable? Scarce life, a filter still awaiting us, or plain cosmic misfortune? Drop your response in the comments, because the debate down there is typically more compelling than the video. Now broaden the scope past just a Milky Way to everything. The observable cosmos contains an estimated 2 trillion galaxies, each holding hundreds of billions of stars of its own. If a handful of Earth-like planets exist per galaxy, that is still a nearly unfathomable count of potential birthplaces for life distributed across all of existence. But scope cuts both directions, and the same expansion that inflates the figures is silently removing most of them from ever being accessible. Space itself is expanding, and it is accelerating, propelled by whatever dark energy truly is. Galaxies beyond a particular distance beyond what is termed the cosmological horizon are, withdrawing from us faster than light, can bridge the gap between us and them. Light departed those galaxies billions of years ago, and will never reach here regardless of how much duration elapses, because the space between is stretching faster than the transmission can close it. It is not a question of them being distant. It is that the path itself is lengthening faster than any traveler can traverse it. Astronomers gauge this stretching with what is called the Hubble rate, and the value itself is almost absurdly tiny on a human scale, somewhere around 70 kilometers per second for every 3.25 million light-years of separation. It sounds trivial until you multiply across billions of light-years of space, at which point the combined stretching between here and a sufficiently remote galaxy accumulates to a recession velocity faster than light itself. Not because anything is physically traveling that rapidly, but because the space in between keeps producing more distance to cover. Every year additional galaxies cross that horizon and become permanently physically inaccessible, not concealed, not quiet by preference, just removed from the collection of locations you could ever conceivably establish contact with, even with boundless duration and boundless capability. Whatever societies exist out there in the overwhelming majority of the cosmos were never contenders for contact in the first place, not because of range in a conventional sense, but because the cosmos itself is actively dragging them out of reach more rapidly each year than the year before. The observable cosmos itself stretches roughly 93 billion light-years measured today, and only a portion of that, a sphere a few billion light-years across, will ever fall within reach of anything originating from Earth at any juncture in the future, even traveling at the speed of light indefinitely. That is the honest magnitude of quiet. It was never truly a detection challenge. It is a geometry challenge embedded in the expansion of space before any society anywhere ever had an opportunity to extend a greeting. Stack these three layers together: scarcity, filters, and light speed geometry, and the quiet ceases appearing like a coincidence and begins appearing like a structural attribute of the cosmos itself. It is conceivable the galaxy has hosted dozens, even hundreds of societies across its 10 billion year history, each one emerging, contemplating, constructing, and declining within its own secluded window of duration, never intersecting with another window closely enough in space or in duration for a single transmission to pass between them. Under that perspective, the cosmos is not barren. It is simply constructed at a magnitude where solitude is close to obligatory, not because life is uncommon necessarily, though it might be, not because every society annihilates itself, though some plainly could, but because the raw geometry of a 14 billion year old, 93 billion light-year wide cosmos makes intersection two minds in the same location at the same cosmic instant, able to perceive each other the exception, not the standard. Feynman used to say that physics does not care what you would wish to be real. It merely describes what is actually occurring, and what is actually occurring according to every fragment of physics available is a cosmos structured in a manner that could effortlessly be full of minds that will never under any circumstance discover the others exist. Fermi asks where is everybody, as though the response had to be either yes or no. Either the galaxy is populated or is barren. Physics suggests a third possibility, he never entertained. The galaxy could be populated, and the quiet would appear exactly the same. Before you settle on which of those three responses you accept, sit with what that genuinely implies for a moment. If the geometry of the cosmos truly renders contact as unlikely, then whatever's unfolding on Earth right now, this precise arrangement of atoms organized into something that can ask, whereas everybody might be one of the only occasions in the history of this galaxy that a mind exists in a condition capable of even constructing the question, not necessarily the first, not necessarily the final, but uncommon enough that the quiet stops resembling emptiness and starts resembling scarcity. Every exchange you have ever had, every bond, every instance of being comprehended by another mind, occurred inside a structural marvel. Two conscious systems inhabiting the same infinitesimally tiny pocket of space and duration, near enough and synchronized enough to genuinely reach each other, zoom out to the magnitude of the entire galaxy and that variety of intersection. The very thing you accept as routine every time you speak to another person turns out to be the rarest phenomenon physics can generate. Think about how carelessly that marvel gets handled. A message goes unacknowledged and it feels like a nuisance. A call gets overlooked and it hardly registers. But run the same occurrence through the physics of this video and a misconnection between two people on the same planet, inhaling the same air, divided by nothing more than a delayed reply, is the exact same category of occurrence as two societies separated by 10,000 light years failing to detect each other, just compressed into a magnitude small enough to feel ordinary instead of cosmic. It places human contact, the everyday variety, in a peculiar new perspective. Every friendship, every exchange, every person who has ever comprehended you, defeated odds that overshadow the ones dividing us from any extraterrestrial society. You did not require physics to explain why that matters, but physics can tell you precisely how improbable it genuinely was. Feynman devoted his life pursuing exactly this variety of humility, not the despair of insignificance, but the peculiar thankfulness that emerges from grasping how slim the odds truly were. Being mistaken about extraterrestrials costs nothing. Being mistaken about how uncommon and delicate this variety of contact is here on Earth costs everything that makes it worth possessing. So where does that leave the original inquiry? Physics presents three candid possibilities, and it does not compel you to select among them. The first is sheer chance. Life itself is simply uncommon enough that Earth might be one of only a handful of technological societies to ever arise in this galaxy's 10 billion-year history. And the quiet is precisely what you would anticipate from authentic scarcity. The second is cosmic separation. The galaxy, or even the cosmos, could be truly teeming with minds, past, present, and future, each one sparking into being and out again within its own slim window, teeming with neighbors who will simply never realize each other exist, divided by light speed and duration in a cosmos too enormous and too ancient for intersection to be the default. And the third is an uncharted principle, some deeper physics, something about the essence of intelligence, capability, or communication itself that has not been identified, yet could be quietly dictating which societies get to perceive each other, and which never will, a rule woven into the architecture of existence that no one has uncovered because no one has understood to search for it. Physics does not reveal which one is accurate. It only reveals this: the quiet you have been contemplating your entire life was never evidence that you are solitary. It is evidence that the cosmos is constructed at a magnitude where solitary and teeming appear exactly the same from within. Somewhere out there at this very moment, something might be gazing back up at its own heavens, computing the same figures, posing the exact same inquiry, and never once imagining that 400 billion stars away, someone already holds the answer to seeking. If this alter how you perceive the quiet in the night sky, subscribe for more physics that challenges everything, and watch the video on screen now for what unfolds the instant two societies actually do establish contact.